Hello, welcome, good morning, everybody. Happy Tuesday. I hope you had a wonderful 3-day weekend and you did something to really consider and be reflective about Indigenous Peoples Day yesterday and why Indigenous Peoples Day is a thing and has to be a thing. So we're keeping that part of history in our minds. Today we're going to be talking about subtracting fractions, doing a little bit of review and circling back to subtracting fractions because that has shown to be a little challenging for folks because it's adding that fractions piece with the subtracting piece. There's a couple of different things that we're working with here, so we really want to focus in on subtracting fractions in isolation today. Here's the things that you're going to need: something to write on, something to write with, and then counting objects if you have them. Okay, these can be anything. Like if you got dry pinto beans in your kitchen cabinet, right? If you've got Fruit Loops, you use Fruit Loops to count. You could use playing cards to count. I happen to be in a fully functioning 5th grade classroom, so I've got linker cubes as my counting objects today. But whatever counting objects work for you, if you find them to be helpful, I would highly recommend it. And I would, ask your grown-ups at home first. But I don't think they would mind if you just ask them, like, hey, can I have can I have 50 tortilla chips to count with today, and then I'll eat them later for a snack? That often are my favorite counting objects at home. Like, use goldfish crackers, because then you can eat them when you're done. Like, especially with subtracting, right? You had 44 goldfish crackers. You ate 7 of them. How many do you have left? Right? You get to do math, and you get to eat delicious goldfish crackers. So there you go. The reason why, first our I cans down here. I can regroup a whole number into a fraction of any denominator, and I can accurately subtract fractions. So the reason why this 44 minus 7 is up on the board here is I do want to circle back to whole number subtraction. Okay? And this idea, because students can and do struggle with subtracting fractions because it feels like a whole new thing. When in fact, it's the same, subtracting is the same no matter your quantities, right? The concept of subtraction, right? You have a thing, you take away some of that quantity, how much do you have left? Or you have 2 quantities and you want to find the difference between the 2 of them, right? Billy walks 6 miles, Jesse walks 8 miles. How many more miles did Jesse walk than Billy, right? There you go. 8 minus 6 equals 2. So we want to go back and we're going to visualize this 44 minus 7 using our counting objects, because when we get to subtracting fractions, we're going to see that it's the same process. Okay? So I've got my counting objects here. It is 44 minus 7. So I've got myself 44 linker cubes. All right? I have 4 groups of 10. For my 40, I'm actually going to stick them in this bag here so I don't have to hold them. Ta-da! Here's my 4 groups of 10, and then I have 4 additional ones. Okay? And I want to subtract 7. Let's zoom in here. I want to subtract 7 from this amount, but I've only got 4. I'm going to take 7 away. I don't actually have 4, right? I have 44. And what do we do when we don't have enough in a particular place? We're going to regroup. We're going to take one of our 10s. We're going to break it up into 10 ones. Yep, that was 10. Just double checking for myself here. So now we've got 3 groups of 10 and 14 ones. Did I grab any other linker cubes from the box right there? No. Did I take any linker cubes out and just throw them away on the floor? Not yet. I will in a second when I subtract this 7. But I didn't change the value here. Okay, all I did was take a 10 and make 10 ones. It's a fair trade. Okay? In both bags, the same number of linker cubes are still there. We've just regrouped them. So now we can subtract and take out 7 cubes. 1, 2, 3, 4, 5, 6, and 7. Subtracted. Now, how many do we have left? We have 3 groups of 10. 3 times 10 is 30, or 3 tens there. And then, how many ones? Let's count up our ones. We've got 1, 2, 3, 4, 5, 6, 7. So we've got 30 plus 7, or 37. Now, there we go. With this problem, right, all we did was regroup, toss it away, right? We've been working on that since first grade, really, kindergarten, TK even, preschool even, how to, add things to a group, take away things from a group. We've been working on that since we were little, okay? Fractions isn't any different. The one change, I'm going to go over here. With this problem, how much was each linker cube worth? Right? This group of 10 isn't just a group of 10, it's a group of 10 whats? It's a group of 10 ones. The size of our piece is 1, okay, or 1 whole. Essentially what we did here (44 wholes, 44 ones, minus 7 ones equals 37 ones. If I were to make this denominator halves, would this sentence still be true? 44 halves minus 7 halves equals 37 halves? You bet. You bet. And in fact, the mechanics of what we did doesn't change either. All that changed was, now instead of the size of a piece being 1, what's the size of each piece? What's our denominator? 1/2. That's the only difference here. Okay? The linker cubes are actually, they stay exactly the same. We've just decided as mathematicians they're no longer worth a whole, they're worth 1/2. Okay, so when subtracting fractions, what we want to do is we want to think about the size of our piece. Okay, the size of our counting object is going to be whatever the denominator is. Let's look at that in practice. I'm going to take out these cubes here and reset for the next problem, which is going to be 3 3/8 minus 7/8 equals what? Okay, so 3 3/8. Let's think about how do we make 3 3/8 with our linker cubes? Well, 3 groups of what here? 3 ones, right? But if we were to just go, okay, well, there's 1, 2, 3, but how do I make 3/8 of this? Scissors. No, not scissors. Come on. What we do here is rather than thinking about each one of these as 1, let's think about our denominator. What's our denominator here? 3 3 whats? 3 3/8. So for each whole number, how many eighths equals 1? Yeah, 8/8. So here's 1, 2, 3, 4, 5, 6, 7, 8 linker cubes, and each one of these cubes has a value of 1/8. So now I can take 3 of our 8/8, 1, 2, 3. There's our 3. Now, how do I make my 3/8? Well, simple. Each one of these equals 1/8, so 1/8, 2/8, 3/8. So I have 3 and 3/8. Now, how do I subtract 7/8 from this? Because I don't have enough. I only have 3. Regroup. And take 1 and break it up into 8/8. 6, 7, and 8. Now, what I have, and I'm going to rewrite it so you can see, I have how many holes here? I have 2. Rewriting. 2. And how many eighths do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 3/8 plus those 8/8 I just moved over. 2 and 11/8 minus 7/8. So that is a rewrite. Now, I can subtract 7/8. So let's subtract 7. 1, 2, 3, 4, 5, 6, and 7. Leaving me with 1, 2, 3, 4/8 remaining. So I have 4/8. Am I done though? No, because I've still got 1, 2 whole numbers here. So 2 and 4/8. And you might recognize 4 is half of 8. So 4/8 is equivalent to 1/2. And we can even see that if we were to put our 4/8 together. And compare it to our 8/8, our whole 1. We can see pretty clearly, right? That's exactly half. The same amount on both sides. 4 plus 4. Okay? So, the key with subtracting fractions, and the most important part to remember, is it's just like regrouping 10 ones into, or excuse me, 110 into 10 ones, or regrouping 100 into 10 tens, or regrouping 1,000,000 into 10 100,000s, right? Except instead of regrouping 10 of them, you're regrouping whatever the denominator is, because that's going to be our unit that we're measuring in. So for instance, if you had something like, I'm going to leave this one up and right below it, okay? If you had something like 4 1/5 minus 3/5, okay? I don't have enough fifths made yet. in order to subtract 1 minus 3. So I've got to make some more. So I'm going to regroup. I'm going to take 1 whole away. 4 minus 1 is 3. And I'm going to make it, I'm going to add it to this 1/5. And so let's think about how many fifths equals 1. That's right, 5 fifths. So 5 fifths plus 1/5 equals 6 fifths. Okay. Just like our original problem of 44 minus 7, I regrouped one of my 4s and I added, or I regrouped one of my 10s and I added, whoops, added those 10 to the 4. Okay, doing the same thing here, except you're not just throwing a 1/10 on the end of it. You've got to add it. 1/5 plus 5 fifths equals 6 fifths. Now we can do 3 and 6 fifths minus 3 fifths equals 3. 6 minus 3 is 3 fifths. Okay? So, same concept. If you don't have enough in one place, you got to regroup it. All right? Same thing we've been doing our whole mathematical careers, except now, instead of regrouping 10, now we've got to think about, okay, what's our denominator? And that's how many I've got to regroup, because that's how many of my, it's how many pieces equal 1. Okay? So if we're regrouping fifths, it would be 5 fifths. If we're regrouping 1 into fourths, it would be how many fourths? 4. If we're regrouping 1 into twelfths, it would be how many twelfths? 12. Okay? Slightly more complicated, but same concept. Okay? Exit ticket is up on Google Classroom. Small group, we're going to start in about 10 minutes at 11 o'clock. Good luck. Remember, anyone is welcome at the small group if you have any questions. And we will see you later. We'll be back here at 12:30 for a writer's workshop. All right. Good luck.